polynomial long division uses the long division algorithm that you may or may not have covered in elementary school in order to extract factors from larger polynomials. We're going to use this to factor cubics and quartics, and we're going to use it to find x-intercepts of cubics and quartics, and then we'll be using it to find end behaviors for rational functions when we get deeper into the unit. So the first skill you have to be able to do is this polynomial long division. So when you see something like this, a power 4 divided by a linear term, you set it up just like you did with long division, like so. And I'm going to divide x to the power 4 minus 6x cubed minus 8x squared plus 40x plus 15 by this thing, x minus 5. All right. So the idea of long division is you're trying to create packages this size in order to divide up this whole long thing into chunks. So I'm trying to break this power 4 into chunks that are this wide. So how many of them would I need in order to make up this first term? That's the first question. So if I was trying to turn an x into an x to the power 4, I'm short an x cubed. So I'm going to write that here. So if I took x cubed of these, x cubed times x is x to the power 4. So that's good. I have a match. That's what I was after. But this little package also has a -5 in it. So I can't just take x cubed times x. I have to take x cubed times -5 as well. And x cubed times -5 is -5x cubed. So I'm going to write that so that it lines up with all the rest of my x cubes. So this times this is this. So if I take x cubed worth of these things out of this pile, I have to figure out what's left. So the x4 is gone. And -6 of these minus -5 of those is -1 of them. Now this thing, which I haven't dealt with at all, that's still here. This is still left in the pile. And this is still left in the pile. So when I extract x cubed x minus 5s from this polynomial, this is what's left. Except that's a cube and that's a square. So now that I've done it once, I just have to repeat this process until I run out of stuff. So what would I have to do to an x to make -1x cubed? Well, I need an x squared, so that x squared times x is x cubed. And I'm going to need a -1 to get the number to match. So -1x squared times x is -1x cubed. Now I'm going to have a piece that sits here because I also have to take -1x squared times -5. So that would be plus 5x squared. This many of those is this much. So I have to take it out of the pile. This, take itself away, is gone. That was the whole point. -8x squared, take out 5 more, is -13x squared. And I haven't done anything with this, and I haven't done anything with this. All right, now that I've got this new pile, my diminished pile, I need to try this process again. So what would I multiply x by to get -13x squared? Well, I need a factor of x to get the x's to be an x squared, and I'm going to need a -13 in order to make the numbers match. So -13x times x would be -13x squared, and -13x times 5 Negative times a negative is a positive. And 5 times 13 is 15. 15 is 65. Take those out of the pile. This minus this is gone. 40 of these minus 65 of those is negative 15 of these. And I've whittled her all the way down to a linear term. So one more iteration of this and I should be done, or at least I'm out of x's. So what would I multiply x by to get negative 15x? Well, that would just be negative 15. So negative 15 times this is negative 15x. Minus 15 times minus 5 is plus 75. Take this out, it's gone. 15 minus 75 is minus 50. Now, I'm all out of x's, right? There's no more functions left here to divide. So I'm finished. Now, I had a number here, which means it didn't divide evenly. So this expression has a remainder of negative 50. I'm just going to toss it up there. Remainder of negative 50. Maybe you remember that happening in elementary school doing these divisions. So what I've just shown here is that this particular question, if I divide this by this, I could write this expression as this cubic, x cubed minus 1x squared minus 13x minus 15 minus 50 that couldn't be divided by x minus 5. So this function up here, as messy as it looks, a power 4 divided by a power 1 looks like a power 3 with this extra little block attached. So when you were to sketch this, this function looks like this cubic almost everywhere. But there's a little bit of nasty business somewhere around x equals 5 that's going to create an asymptote. So we'll get how to figure that out later. But this function divided by that one, you use your algorithm, spits out a polynomial with a remainder written like that. So in the next section, we're going to start sketching cubics in Cortex. And the points that we're going to use are the y-intercepts and the x-intercepts. We'll talk about that more later. But to get x-intercepts, you take the function you're trying to solve and you set it to 0. Now, the problem with this is you have numbers with no x, numbers with x's, x's squared, x's cubed, x's to the power 4. You can't use linear algebra on this because it's not a linear expression. When it was just a parabola, even, just these three terms, you still couldn't use linear algebra. You had to pull out the quadratic formula in order to pull that off. And there is no such thing as the quartic formula. You could probably sit down and write one if you wanted to, but I imagine it would get so complicated that there's probably a better technique to do it, like polynomial long division. So the limitation to this particular tool is you have to do a bit of guessing and checking first to find at least one x-intercept. So I'm going to pick, let's say, how about 2? Let's try 2. Okay, so 2 to the power 4 would be 2 times 2 is 4, times 2 is 8, times 2 is 16. 2 cubed is 8, 8 times 5 is 40. 2 squared is 4, 4 times 7 is 28. The 2 in here, that's 82, minus 30. Let's see what we get. Well, minus 40 and minus 28 is minus 68. Minus 30 would be minus 98. And 82 plus 16 is 98. So 98 minus 98 is 0. That one worked. So what I've figured out there then is that since because this function at 2 equals 0, then x minus 2 must be a factor. So I'm going to divide it out. Because if I divide it out, dividing a linear out of a power 4 should leave me with a cubic, and that's easier to work with. So in order to get that out of the way, I have to take this power 4 function and divide out this factor. So I'm going to set up the division. X to the 4 minus 5x cubed minus 7x squared plus 41x minus 30 divided by this factor of x minus 2. All right. So what times x gives me an x to the 4? Well, that's x cubed. X to the 3 times x gives me x to the 4, and I get a negative 2x cubed for free out of the deal. Take this out of the pile, it's gone. Minus 5 minus negative 2 is negative 3x cubed. This is still in the pile. This is still in the pile. This is still in the pile. So, rinse and repeat. What would I have to multiply an x by to get a negative 3x cubed? Well, it would have to be a negative 3 to get the note 3, and an x squared to get the cubed. Minus 3x squared times x is minus 3x cubed. Minus 3x squared times minus 2 is plus 6x squared. Take this out of the pile, that's gone. Minus 7 minus 6 is minus 13x squared. And this is still there, and this is still there. So I ask myself again, what would I have to multiply x by to get minus 13x squared? Well, it would have to be minus 13x. Minus 13x times x is minus 13x squared. I think my blue has finally bit the biscuit. Minus 3x times minus 2 is plus 26x. For a total of minus 13x squared minus 13x squared is gone. 41 minus 26 is 15. And this is still there. So what would I have to multiply x by to get 15x? Well, just 15. 15 times x is 15x. 15 times minus 2 is minus 30. For a total of none. This one divided evenly. Now, that must be true. If x minus 2 is a factor, then this thing has to divide evenly by that factor. So I should get a nice clean answer at the end. So what I've just shown, I'll get rid of this 0 for a minute, is that this power 4 can be written as x minus 2 multiplied by this cubic. So I've taken this power 4, I found an answer that worked, divided it out, and left only a cubic behind. Now I'm not done yet. I mean, this thing may have factors as well, but because it's a cubic, it's easier to do, because I peeled this one out of the way. So I'm back to the beginning again. I have to look at this cubic, and I have to see if I can guess a number that divides evenly. So I'm just going to erase this part here. All right, so looking at those numbers, I feel 1 in our future. 1 and 15 would be 16. Minus 3 and minus 13 would be minus 16. So let's try x equals 1. So I would end up with 1 cubed minus 3 times 1 squared minus 13 times 1 plus 15. And that's 1 minus 3, which is minus 2, minus 13 is minus 15, plus 15 equals 0. Lo and behold, it did work. So, because f at 1 equals 0, x minus 1 must also be a factor. So I'm going to factor this x minus 1 out of the cubic that remains. So if I set that up, divide x minus 1 out of the x cubed minus 3x squared minus 13x plus 15 that remains. So what times x gives me x cubed? Well, that has to be an x squared. X squared times x would be x cubed. X squared times minus 1 is minus x squared. Take them out of the pile. This minus this is gone. Minus 3 minus minus 1 is minus 2. And this is still there. And this is still there. Rinse and repeat. What times x gives me minus 2x squared? Well, I need a negative 2 to get the numbers to match. And I need an extra power of x to get it done. So minus 2x times x is minus 2x squared. Minus 2x times minus 1 is positive 2x. Take it out of the pile. This minus this is gone. Minus 13x's minus 2x's is minus 15x's. And this I haven't touched yet. So what times x gives me negative 15x? Well, it's just negative 15. This times this is this. Minus 15 times minus 1 is plus 15. And it has divided evenly again, which is, again, encouraging. If this worked, it must pull out evenly. So what have I figured out then? Well, this cubic here, I don't have to write this as a cubic. I could write it as x minus 1 times this polynomial. So if I just get rid of that then. X minus 1 times this polynomial here. Well, now that I have this is just a parabola. And we're real good at factoring parabolas. And even if it doesn't factor, you could use quadratic formula on it. So we've broken this power 4 polynomial first into a cubic with polynomial long division, and then broken the cubic into a parabola with polynomial long division, which got us back to something that we could handle. This one, if I look for two numbers that multiply to minus 15 and add to negative 2x, that's minus 5 and positive 3. So I don't even need to write this. I need to write minus 5 and positive 3. All right. So after all that work, I took this power 4 function and I broke it up into its 4 original factors. Now, originally I was asked when this thing equals 0. So case 1, x minus 2 equals 0. Therefore, x is 2. Now, I had guessed that one. Or case 2, x minus 1 equals 0. So x equals 1. I had guessed that one as well. Or this one, x minus 5 equals 0. So x is 5. Well, I didn't know that one, but I figured it out now. And then this last case, where x plus 3 equals 0. So x is negative 3. So I have 4 solutions. This particular function, this polynomial, is worth nothing when x is 2, x is 1, x is 5, and x is -3. So if I were to sketch this thing, which we'll do a little bit in the future, I've just found that there are 4 x-intercepts. So when I start drawing this wiggly thing, I've been able to figure out the 4 places it crosses the x-axis. Couple that with the y-intercept, and we've got enough to do a sketch.